Yes, so let us start the session. Others will join soon. Yeah. First of all, let us briefly recap what we have discussed so far so that we can continue this particular session. Now, coming to this particular session, we have discussed, we have started with our verification plan. We have discussed the structure of our test bench and what is our design which we are going to verify and what are the test case, what do you mean by interface, what is top model, and we have also seen about what type of transaction we are going to have and what are the steps of developing your system Verilog test bench, right? And also we have discussed about generator class and what is that we are going to develop and how the transaction is going to send the transactions to my driver and how the driver we are going to have and how the generator we are going to have, right? So this is all we have discussed it, and we have also discussed about the decoder based RAM, what are the inputs and what are the outputs and what is the internal structure of this decoder based RAM and about the addresses and all. And afterwards we have developed the interface and we have started with the development of a transaction. And in today's session, let us develop the code for our generator. Okay, so this is what we have discussed so far. And if you are new to this particular session, I recommend you to please go through the recordings which are available so that you will be clearly understanding what is happening over here, right? Yes. So let us start with this session. So let us continue with our code. Like we have initially discussed about the interface, and next we have started with transaction. And give me 1 second. Yeah, there was some disturbance out there. So let us try to develop our generator. The main goal of developing our generator and what is the role of our generator. In our previous sessions only we have discussed it briefly, and here also we will discuss briefly like what is generator is going to do. So we had a transaction class which is going to have the input stimulus which is being declared as your rand and also some of the output signals which have been declared. And apart from that we were having the generator class, right? So this particular generator class is going to randomize the variables which have been declared as input, right? So in the inside my generator I'm going to call the randomize method, and I'm going to randomize the transactions which are present inside my transaction class. I'm going to randomize the variables which are declared inside my transaction class, right? Now, so this particular generator class, after randomizing this particular transactions, it is going to send this particular transaction to my driver via the mailbox. So I'm going to use a mailbox and I'm going to send it. Okay. This particular code we are going to see it now. Okay, how to develop it. So I'm going to have a simple generator class. I'm writing everything in the same file. Okay, so that it is easier to you to understand what is the code and where is the code. And after that, I will send each separate files which I've already written so that it will be a neat and organized manner. Right now, let me write down my class. And the class name is ram underscore generator is the class name. And here, what are we going to do is we are going to have few mailbox handles. Let me write it down over here. So in this particular class, we are going to have, I'm going to declare mailbox handles, mailbox, and this particular mailbox handle should only accept my transaction class data. Okay. So here, what is my transaction class name? It's simply transaction. So mailbox hash transaction. So this mailbox is only going to accept this transaction and it is write mbox. So this mailbox is used to send the data to my write driver. Okay. And I have another mailbox which is also going to accept the transaction data only, and it is read mailbox. So this is used for sending data to read driver. Now, I'm also going to have one more mailbox for getting the acknowledgement from my driver. So, driver after driving the data, it is going to send some acknowledgement via the mailbox to the generator. Okay. For that purpose, I'm going to have another mailbox. Let me declare it over here. Mailbox. and it is of only bit. That means it can only have either 1 or 0. And the mailbox name, let us say it as write underscore done underscore mailbox. This is used for just getting acknowledgement from the driver. Okay, so this we are going to use from the driver, which is right driver. Okay, this is just for getting the acknowledgement from the right driver, and how it is going to use, I will show you. Okay, and another thing is int unsigned num underscore writes, that is number of writes, for tracking the number of how many number of writes I'm going to have, and also for tracking how many number of reads I'm going to have. I'm going to declare those particular variables. And yeah, now, after this, I'm going to use my constructor. Okay. So this particular constructor, I'm going to declare function new. About this constructor also, we have discussed it a lot in our sessions, like how this constructor is being used and how it is being called and where it is being called and when it is called. This is very, very important, and we have discussed this. Okay. And this constructor, I'm going to declare few arguments: mailbox, transaction, right underscore mailbox. This argument we are expecting whoever is going to call the new function, they should pass this mailbox argument. Okay. And apart from that, we are going to have mailbox hash transaction read underscore mailbox. Okay. And followed by mailbox hash bit right underscore done underscore mailbox. I have a question over here. Uh, how to use a mailbox? Can we use a mailbox directly, or what is the process? Like we have seen, right? If you want to use a mailbox, you need to create the instance of that particular mailbox. Now, when we were discussing about mailbox, we have took an example of two modules placing side by side, and if they want to communicate with each other using the mailbox, where is the mailbox instance created, guys? Where was the mailbox instance created when we were discussing about that particular example of two modules communicating each other with using mailbox, where we have discussed that particular instance of the mailbox? Anyone remembered? Where was the instance exactly? Not environment. In that particular example, in the top module. Okay, here in our scenario, we are going to declare the instance in the environment. You are correct. Okay. Now, once again, I'm repeating this particular point. If you want to use a mailbox, you need to create the mailbox instance. You need to create the mailbox instance. Then only you're going to able to push the data or pull the data from it. Okay. Now, if you're going to have different components, like in our example, we have a generator and we have a driver which is present over here. Precisely, it is read driver, right? Now, this two wants to communicate with each other using a mailbox. These two want to communicate with each other using a mailbox. Now, mailbox instance we should not create in a generator, or mailbox instance we should not create in a write driver. We should create the instance of the mailbox in such a way that in the top of these two modules, that is nothing but my environment. Environment is going to have generator and write driver, right? So that's the reason mailbox instance is created in my environment. So here in the environment, we are going to create the mailbox instance, and this mailbox instance will be given to your generator and to your write driver. If you have remembered when we were discussing about the concept of mailbox, this is the same thing which I've told you. Okay, I'm going to create the environment. I'm going to create the mailbox instance in a top model, which is top to both the components, and then I'm going to pass it to my generator and write driver. Okay, is it clear, guys? And in system verilog, if you want to pass any handle or any particular instance from one top model to the lower level models, you are going to use a new. Okay, you can use this new constructor. Is it clear? You're going to use this new constructor for passing the handles or the instances from the top level model to the lower level model. Can't we use any other function apart from new for passing the handles from the top level model to lower level model? Can't we use any other functions apart from this new? So this was question asked in one of the interview. Like the candidate was explaining, and he told that we can use this new constructor for passing the handles or instances from top level module to level module. So the question was like, can't we use any other methods for passing the handles or instances from the top level module to the lower level module? Can't we use? Yes or no, guys? What do you say? Yes, we can use any method. Okay. For example, instead of this new in the right driver, I can declare a method which is known as get underscore mbx method, which is expecting a mailbox handle. Okay. So inside my environment, what I will do using the right driver instance, I will call this method and I will pass this instance. That's it. There is no need of using new now. Okay. Is it clear? Am I audible? Please let me know. Am I audible, right? Yeah. Okay. So this is where I can use this new for sending the data or the top level instances to your level model. That's the reason I'm declaring them in my new function as my arguments. So whoever is going to call the new method, that is environment is obviously going to call the new method of this generator, then it is going to pass the right mailbox instance, read mailbox instance, write done mailbox instance. Okay. And also it is going to expect one argument which is num underscore writes, and the default value, let us keep it as 32. Okay, so number of writes I want to, and number of reads also I'm going to keep it to 32. So 32 number of reads and 32 number of writes are default, and if the user wants to override, like if he wants to perform more number of writes or more number of reads also, he can configure it. Okay, now I'm going to assign it to my local copies. Write underscore mailbox is equal to write underscore mailbox. And this dot read underscore mbox is equal to read underscore mbox. And this dot write underscore done underscore mbox, write underscore done underscore mbox. And this dot num underscore read is equal to num underscore read. That means whatever the user is sending via the arguments, that I'm copying it to the local copies. That's it. And this dot num underscore read is equal to, sorry, num underscore write is equal to num underscore write. Number of writes I'm copying it. And followed by end function. If you're not aware of what I'm going to do, like how I'm copying the mailbox instances and all, I recommend you to once rewatch the mailbox concept which we have discussed, right? Now, so this is new function. This is the initial step which we have done. Now, what I'm going to do is I'm going to have a task which is known as a run task. Why I'm going to take a task? Because task can have delays. So for running a transaction, I might have some amount of delay. Okay. So here I'm going to first of all declare my transaction handle. Let's say it is TX. And also I'm going to declare a dynamic array over here of data type. Let's say of it is of 6 down to 0. It is of logic data type. And I'm going to store the addresses. Whatever the address which I'm going to have, that I'm going to store it inside this dynamic array, which is nothing but return underscore address. And the address width is 7-bit, right? So that's the reason I'm going to have logic 6 down to 0, right address. Okay. Now, for this, I'm going to create the memory because it's a dynamic array we are going to have. I'm going to create a memory for this. Now, after that, I'm going to have different phases. Let's see the phase number one. So in the phase number one, what I'm going to do is I'm going to first of all generate the transactions. How I'm going to generate? So using a for loop for int I is equal to 0, I less than number of writes. Here in this particular case, 32 writes, 32 write operations. This for loop will be iterated for 32 number of times. I'm going to increment my I value. So here I'm going to first of all create the instance of my transaction, and next Since it's a write operation, inside your transaction file, you can check it out. We have a variable which is known as OP. So OP basically can have two values, either write or either read. Okay. This I don't want to randomize it now. Okay. I'm basically targeting a write operation, a specific write operation. That's the reason I'm going to make this OP value to be write. So I'm going to use my transaction handle txn dot txn dot I want to access it. op is equal to write. Txn dot op is equal to write. That means I want to perform a write operation. Okay. Now I'm going to randomize, apart from this op, I'm going to randomize everything. So what are the things which I want to randomize is address. I want to randomize data, this address and data I'm going to randomize, and OP I've already given as write. Okay. So let's randomize it. So how I'm going to randomize? So I'm going to write it down within an if loop. So if txn dot randomize. So if txn is not randomizing, and I'm going to use an inline constraint. What do you mean by an inline constraint is, you can, when you're going to randomize, you can, at the same time, you can provide the constraint using the keyword with. Okay. This is nothing but my inline constraint. Here, what is the constraint I want to have? OP is equal to write. This is the inline constraint which I'm going to provide. That means I want to perform a write operation and followed by semicolon close. If this is not going to happen, okay, if this particular condition is not going to happen, then what I'm going to do is, sorry, this is if loop, right? If this condition is not going to happen, then I'm going to display randomization fail. Okay, so this is what I've done. Is it clear, guys, what I'm going to do? Hello, am I audible? Is it clear? Any doubts or any queries? And I'm going to end this. Now, if randomization has successfully completed, then what I'm going to do is I'm going to store the address inside my array. So return underscore address is equal to whatever the randomization happened, that particular address I want to store. Okay. And I'm going to use my mailbox, right, underscore mailbox dot put of transaction. Okay. This is a simple step which I've done over here. Okay. So after this mailbox has sent the data to my driver using the mailbox, after this generator has sent the data to my driver using this particular mailbox, the driver, it is going to send me the response. Okay, after driving, it is going to send me the response. Okay, how I'm going to model that? I'm going to model that using simple a variable which is known as token. I've declared some random variable bit token. So I'm going to use a for loop for I is equal to 0, int I is equal to 0, I less than number of writes I plus plus. Here, what I'm going to do is write underscore, for getting the response from your driver, I was using a mailbox handle. Where is it? Yeah, this write underscore done underscore mailbox. This mailbox I'm going to use dot get of. I'm going to store the acknowledgement inside this variable which is known as TOK. If this TOK is equal to 1, then we will come to know that okay, write operation has been completed, or else we will come to know that okay, write operation has not been successful. Okay, and followed by end. That's it. So this is nothing but my write operation which I'm going to perform, and this is phase one. So in phase one, I'm directly performing the write transactions by randomizing the other variables like address and data. Okay. Yes. So any doubts or any queries, guys, up to here? Sorry. Yeah, yeah. Okay, great. So we will continue this particular code, and we have different scenarios where we are going to target. Like this is only the one test case which I have shown you, and you can also try. Like this is for writing the data. Okay. And next scenario we are going to have for reading the data and also uh, generating random multiple data address for multiple blocks. Okay. And also generating everything random. Okay. So that is fourth phase. Okay. So like we are going to have four phases which I am planning. Okay. So this is phase one. Using phase one, if you want to perform read operation, you can also try it out. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries you wanted to discuss with me, you can stay and discuss, or else you can leave the session. Okay. Thank you. Good night.